The rain came in thin silver wires that December morning, swept sideways across the foredeck of a destroyer that had already seen too much ocean for its young crew. The ship's name was USS Cushing, a Fletcher-class tin can sliding through the North Pacific in the winter of 1943. Her grey bow knifed into swells that rose like slate mountains, and every impact shuddered through the frames, rattling coffee cups and loosening rust flakes from the overhead pipes. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. Men moved carefully, gripping stanchions slick with salt. The deck pitched, then pitched again, the horizon vanishing behind walls of water. Somewhere below the waterline, oil-soaked machinery hummed with weary resolve. Forward, at frame 68, near the break of the main deck, a welder named William Red Taggart stood in a cramped compartment facing a hull plate that refused to behave. Red was 29, red-haired in truth, and even in the cold he perspired under his leather apron. The weld seam bulged slightly where it met another plate, forming a shallow but unmistakable angle wrong by the yard standards, wrong by naval blueprints. He hadn't angled it for aesthetics. He had angled it because he believed it would keep men alive. 2 hours earlier, Cushing had fired 5-inch shells at a suspected Japanese coastal battery while maneuvering beyond the Aleutian Dark. The return fire had been heavier than expected high-velocity shells, likely from a surviving dual-purpose mount. One of them struck along the starboard bow, just above the waterline. The impact should have opened the hull like a sardine tin. It didn't. The shell, broad-shouldered and confident, struck the angled plate and slewed off, screaming away into the cold air. Shock waves rolled through the compartment. The crew stood, stunned. Taggart had helped design that repair weeks earlier, at Mare Island Navy Yard. He wasn't an engineer. He wasn't a naval architect. He was a welder who had spent most of his life shaping metal because textbooks made his eyes blur. But he knew metal like other men knew prayer. Now, in the dim compartment, he touched the welded angle with his gloved hand. This moment, this deflection would ripple far beyond Cushing's hull. It would challenge accepted truths about steel, about the limits of American shipbuilding, and about what one man with a stubborn idea could change. If this angle had truly saved the ship, then everything the Navy believed about destroyer protection would have to be questioned. That was the problem. Ideas, especially good ones, had a way of threatening the men who never imagined them. The story of how that angled plate came to be begins long before the shell strike, in another winter, at another yard, when the war felt both far away and unbearably close. The year was 1942. The United States Navy was reeling from the devastation of battles it barely understood: Coral Sea, Midway, the night maelstroms off Guadalcanal. Destroyers, the blue-collar workhorses of the fleet, had been thrown into violent knife fights in the slot, where Japanese torpedoes and high-explosive shells tore into thin hulls designed more for speed than protection. They were called tin cans because that was what they were: thin-skinned, lightly armoured, built to chase submarines and screen capital ships, not dual cruisers in the dark. The doctrine that shaped them had been clear since before the war. Destroyers were expendable. Their survival was a luxury. Their purpose was to keep the enemy away from bigger, more valuable ships. No one expected them to stand and trade gunfire with heavy cruisers. Yet, in the jungled waters north of Guadalcanal, that theory collapsed under the weight of frantic necessity. William Taggart was nowhere near those battles. He was working nights in a drafty corner of Philadelphia Naval Shipyard, a place thick with welding fumes, clanging hammers, and the raw metallic smell that stuck to your clothes. He had grown up in Bethlehem, Pennsylvania, in the long shadow of blast furnaces that fed steel into the arteries of a growing nation. His father had been a cinder-covered furnace man. His mother died when he was 8. He learned early that metal was both friend and enemy, strong enough to build bridges, brittle enough to fail without warning. When the war came, he followed the steel. He found work in hull fabrication, welding plates for destroyers built on rushed schedules. Designs came down from Washington as if etched in stone, angles, curves, thicknesses, all dictated by men with degrees from Annapolis and MIT. But Taggart noticed things. The vertical hull plates in the bow section buckled too easily when subjected to stress. Even minor collisions during sea trials caused subtle distortions. It was chalked up to wartime production pace. But Red, who had shaped steel since adolescence, knew it was more than that. The plates were taking impact head-on rather than deflecting it. He remembered something his father taught him near the furnaces. A blow that slides glances away. A blow that lands square breaks you. His father had been talking about fists. It applied to steel. The Navy's hull design was built around straight lines, flat plates joined vertically to the keel and frames. Simpler to fabricate, faster to build. But speed in construction meant predictability. Predictability meant vulnerability. Taggart thought a slight angle in certain hull plates, especially near the bow, might coax incoming shells away rather than inviting them in. It wasn't armor. Destroyers didn't have armor. It was geometry. He tried to raise the idea. The foreman grunted. "We build what they send. You want angles. Go be an engineer." Naval architects dismissed him with polite indifference. Their drawings were optimized for watertight integrity, manufacturability, and internal layout. The bow plates' angles were chosen to balance hydrodynamics and framing simplicity. A few degrees here or there might complicate fairing, introduce structural stress, slow production. No one wanted to hear from a welder with high school math and calloused hands. But Taggart kept thinking. In early 1943, he was assigned to Mare Island Navy Yard in California, repairing battle-damaged destroyers returning from the Solomons. The ships limped in, scorched and bent. Some had gashes you could walk through. He saw how shells struck vertical plates. He saw the clean, awful entry wounds, steel pulled inward like torn paper, jagged and unforgiving. He also saw cases where shells had hit irregular surfaces, misaligned plates, temporary patches, and had skidded off instead of punching through. These accidents were suggestive. They whispered that deviation could be advantage. He began experimenting quietly during repairs, adjusting plate angles by small degrees when fairing allowed. Official specifications required strict conformity, but wartime reality bent rules. Ships needed to return to sea fast. If an angle line drifted by a degree or two, no inspector was likely to halt the work, especially if the fit was tight, the seams clean. The first time he tried, it felt like sin. Warships were scripture, the blueprints were gospel. But then he watched a patched destroyer, USS Caldwell, depart for the South Pacific with a subtle angle in a forward repair. The change was nearly invisible unless you knew where to look. He stood by the pier, wiping his gloves on his overalls, feeling like he had drilled a secret into the bones of a machine. Whether it would matter, he didn't know. What he did know was that the doctrine governing destroyer hulls had been forged in a peacetime navy, shaped by assumptions about the roles these ships would play. Destroyers were conceived as scalpel, not shield. Their hull plates were thin, often little more than half an inch of steel, because speed mattered more than protection. Even after the lessons of Iron Bottom Sound, the fundamental truth remained. You couldn't armor a destroyer without turning it into something else entirely. American naval doctrine at the time was profoundly influenced by gun theory developed between the wars. Battleships and cruisers carried the armor. Destroyers relied on maneuverability. The primary threat was believed to be submarines. So destroyers carried sonar and depth charges, sweeping ahead of larger ships to detect underwater threats. Surface combat at night against cruisers loaded with 8-inch shells was not in the script. Yet that was exactly what had happened in the chaotic battles off Guadalcanal, where American destroyers bled to keep transports alive. Stories filtered back to the yards, of ships blasted in half, of decks awash in flames, of men jumping into water slick with oil, lit by gunfire like hell's own lanterns. Hulls that survived carried scars that told unmistakable stories. Vertical plates yielded, folded inward under high-velocity impact, seams ruptured along the frame lines. Taggart read everything he could: damage reports, engineering memos, accounts from returning sailors. He scribbled notes on scrap paper, sketching arrows to show the direction of force, drawing angles like a man possessed. He began to believe that even small deflection changes could divert catastrophic penetrations. Not prevent them entirely, just tilt the odds toward life rather than death. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. His opportunity came in late autumn of 1943, when USS Cushing arrived at Mare Island for rapid repairs before redeployment. She had been escorting convoys and conducting patrols near Attu, where cold gnawed men to the bone and the sea cared nothing for heroism. Cushing needed work new plating near frame 68, where seawater had seeped through strained welds under repeated pounding. It was ordinary work, necessary work, work that was expected to be done fast. Taggart requested assignment to the hull team. His lead, a weary superintendent named Jacobs, approved without thought. Cushing's bow was opened to the cold air, her internal spaces stripped to bare framing. Taggart stared at the section he would rebuild. The existing plates were vertical, squared to the internal structure. They did their job, but barely. He proposed to Jacobs a repair that would slightly angle the new plates outward subtle, no more than a handful of degrees, enough to encourage glancing impacts. Jacobs shrugged. If it fits and passes inspection, fine. We're behind schedule. Taggart and two helpers set to work, trimming plates, heating edges, bending sheets to the new angle. Fairing became a quiet war, ensuring the outer hull looked continuous despite internal misalignment. He welded carefully, each bead steady, breathing in fumes while his face shield reflected blue fire. Days later, the section passed inspection. No one noticed the angle. No one but him. Cushing left the yard before Christmas. Taggart returned to other ships, filing away the memory of his small rebellion, uncertain whether it would ever matter. Months later, in the North Pacific, a Japanese 5-inch shell found that same angled plate and ricocheted, sparing Cushing a likely breach just above the waterline. Word of the deflection travelled through the crew like electricity. Some credited luck, others called it providence. Bosun's mates chalked a small white mark near the deflection scar, a quiet shrine to survival. When Cushing returned to port for resupply, Taggart saw the scar. He ran his fingers along the metal where the shell had kissed and turned. He saw the angle, and he felt something like vindication. It wasn't armor, it wasn't magic, it was geometry. That moment did not rewrite doctrine overnight. The Navy was cautious, slow to accept innovations born on the shop floor rather than the drafting room. But the incident sparked conversations. A division officer aboard Cushing filed an after-action note describing the deflection. At Mare Island, engineers examined the repair. At first, they questioned whether the angle was intentional. When they learned it was, some frowned. Others listened. One junior engineer, a bespectacled graduate from the University of Michigan, saw promise. He pored over penetration tables, comparing impact probabilities. He calculated that at certain oblique angles, even thin plating could redirect shells that would otherwise tear through. He wrote a memo. Small angles might offer tactical survivability in the forward sections of destroyers operating in contested waters. The memo circulated quietly, among officers who had seen too many tin cans torn open like fruit. It might have ended there, another forgotten footnote in a war of overwhelming scale, but the story of that angled plate found its way to men who remembered the night actions off Guadalcanal. They knew that small advantages mattered. They knew that survival often turned on a detail. The challenge, however, lay not only in physics, but in belief. The Navy believed in speed, not protection. It believed in doctrine forged in the interwar years, where battleships ruled and destroyers screamed. To suggest that destroyers deserved even modest changes in survivability meant challenging foundational assumptions. It demanded admitting that destroyers were fighting battles they were never designed to fight. For many, that was an uncomfortable truth. Yet truths have a way of emerging, especially when they are etched by fire into the hull of a ship. The months that followed saw quiet experimentation, some sanctioned, some improvised. Repair yards, angled plates subtly near the bow and along critical areas adjacent to magazines. The changes were small, constrained by the existing framing. But the idea lived, whispered among welders and fitters who respected results more than hierarchy. Taggart, still working long nights, heard rumours of other ships returning with similar deflection scars at angled repairs. He didn't celebrate. He simply continued shaping metal, certain only that his hands knew things blueprints sometimes forgot. As 1943 bled into 1944, the destroyer force continued to fight across two oceans. Some returned, some did not. In quiet corners of the yards, a new respect for small angles took root. It was not doctrine, it was not standard, but it was possibility. Possibility born from one welder's stubborn conviction that a plate could be more than a barrier, it could be a guide, coaxing death to pass by instead of enter. And in a war measured in lives and steel, that was no small gift. Yet, for all its promise, the welder's idea remained little more than a quiet note passed among steelworkers. Officers and engineers still believed that hull plates were for buoyancy, not protection. Angles were for tanks, they insisted, not ships. Nobody wanted to hear theories from someone wearing a leather apron instead of dress blues. So the thought of deflecting naval shells off a destroyer's side slipped into the background, one more gamble left unexplored. Months passed. Ships were launched, battles fought, and the Pacific grew redder by the day. But fate has a way of testing ideas no matter who they came from. In 1943, a new destroyer sailed into the Solomon Islands. She was barely broken and still smelling of paint and oil when the night lit up in fire. Star shells cracked overhead, cutting the darkness into harsh white geometry. Then came the Japanese guns. Their 5-inch rounds screamed through the air and hammered toward the American hull with murderous intent. One of those shells struck the ship just aft of midsection. Men clenched their teeth, bracing for the blast that should have torn deep into the machinery spaces. It never came. The shell struck at an angle not flat, not square, and instead of biting into the steel, it skittered sideways. It ricocheted, spun across the surface like a stone skipping off a lake, and detonated harmlessly in the sea. The crew stared in disbelief. Damage control teams ran to the impact point expecting the worst. But there was no inferno, no flooding, no screaming order to abandon the compartment. Just scraped paint, bent plate edges, and a story that seemed impossible. A 5-inch shell had hit a destroyer and failed to penetrate. Word travelled faster than any cable. Officers traced the section of hull where the shell struck and found something curious. The plates there were subtly slanted, just a few degrees more than standard. Enough to change destiny. Quiet conversations began. Someone in the yards had done this deliberately. Someone had been thinking. Reports followed. Engineers inspected, sketched, measured. They ran stress analyses, trying to understand how something so simple had turned a lethal strike into a harmless deflection. There was no magic, only physics. The angle forced the incoming energy to travel sideways through the plates, rather than inward toward the vital heart of the ship. What should have punched through had instead been persuaded to look for another path. Slowly, attitudes changed. No announcements were made, no admiral wanted to admit that a welder may have solved something their academies had overlooked. But in drafting rooms, designers began incorporating more angled regions along midship zones. Not armour in the traditional sense, just smarter geometry. They did it quietly, just in case someone asked too many questions. In the yards, the story spread among workers. They spoke of the welder who had seen what others missed. His adjustment wasn't dramatic, just a small rotation of steel, a humble shift in perspective, but at sea, where shells fly and ships bleed, Even a handful of degrees can draw the line between life and death. Sailors began to notice that enemy rounds behaved strangely when they hit these new plates. Some shattered, some broke apart. Others skipped entirely, leaving ugly scars on the hull but sparing the men inside. Many didn't even realize that the ship beneath their boots owed them this grace. The welder who started it all remained invisible. He had no command, no medals, no desk with his name engraved. He worked with sparks and heat, not textbooks. While others debated theories, he adjusted steel by feel, trusting instinct born from countless hours living inside the rhythm of a torch. He never claimed brilliance. He simply believed he could make something better, and then he proved it, even if no one knew his name. Somewhere in the Pacific, destroyers returned home with battered hulls. Their sides were bruised with scars, small reminders of nights when death came calling but failed to enter. Each scar was a story of men who lived because a shell turned away at the last second. They never knew who they owed. They only knew they lived. And all because one quiet man, deep in the roaring belly of a shipyard, looked at a flat plate of steel and thought, there must be a better way. The weeks turned into months, and the war raged on. Each engagement in the Pacific brought new tests, new enemy shells, and new opportunities for the subtle ingenuity of the shipyard to prove itself. Reports from the front lines began to shift. Admirals, once skeptical, could not deny the trend. Destroyers with slightly angled hull plates survived strikes that had once spelled certain destruction. The numbers were undeniable. Casualties fell in areas once considered extremely vulnerable. Hull breaches became rarer, and ships returned to port more often intact than they had in prior campaigns. Naval architects, now forced to reckon with reality, began incorporating the principle into broader designs. Not all ships could be retrofitted immediately, but lessons from the field influenced new destroyer classes. Engineers started to calculate the exact angles that would maximize deflection without compromising structural integrity. The mathematics of the angle became a quiet obsession in the yards as draftsmen drew lines, revisited stress tables, and reviewed battle reports. They were no longer just building ships, they were sculpting survival. The irony was not lost on the crews. Men who had once feared the relentless rattle of enemy guns found themselves watching shells glance off steel with disbelief. The psychological weight of battle shifted subtly but profoundly. Where before they had braced for certain death, now they moved with measured confidence. Each deflected shell became a lesson in chance tempered by ingenuity, a silent proof that human judgment, even outside command, structures could alter the deadly calculus of war. Word of the phenomenon eventually reached higher levels of the Navy. Internal memos circulated, cautiously praising the field adjustments while maintaining bureaucratic distance from the unknown originator. The war, after all, demanded proof, not legend. Yet the story seeped into shipyard culture, inspiring a generation of welders, fitters, and fabricators to consider the unseen angles of every plate and beam. Creativity, once sidelined by rigid specifications, became a tool of survival. By 1944, when the United States Navy pressed its advantage in the Philippines and the Central Pacific, destroyers were routinely outfitted with slanted plates in critical areas. Even in the heaviest bombardments, these ships suffered far fewer catastrophic hits than their predecessors. Sailors, many of whom had trained under the grim shadow of high casualty rates, now had tangible reassurance. Could save many of them. The very structure beneath their feet was working with them, not against them. After the war, official histories would highlight production numbers, strategic victories, and major battles. Few would acknowledge the quiet innovation of a single shipyard welder, yet his contribution endured in the form of countless lives spared and ships returned safely to port. His was not a story of fame or medals, but of insight, attention, and courage in the face of the ordinary repetitive work of steel and fire. He proved that sometimes the smallest adjustments, an angle here, a shift there, could ripple outward to shape the fate of men, machines, and nations. In retrospect, the lesson was clear. War is measured in grand strategies and fleets, but survival often depends on the quiet, patient wisdom of individuals who see what others do not. A single plate of steel, angled just so, became a symbol of that truth. It reminded sailors and shipbuilders alike that ingenuity, care, and attention to detail can transform ordinary tools into extraordinary shields. And in the Pacific, as shells screamed overhead and water churned around the hull, that small human insight became the difference between life and death. Decades later, when veterans recounted the war, some spoke of miraculous survival, of ships that endured what should have destroyed them. Few knew the name of the man who had tilted those plates, but the evidence of his work was everywhere. It was in the lives saved, the missions completed, and the subtle but decisive edge that allowed the United States Navy to endure. The war had been vast and terrible, but within it, the quiet power of human judgment, the spark of observation, the courage to try something unconventional, had left an indelible mark. The destroyers that returned, scarred but steadfast, were more than vessels of war. They were testaments to ingenuity, persistence, and the invisible hands that bend reality in the smallest ways. They told a story of how, even in the largest and most destructive of conflicts, survival often hinges not on numbers, doctrine, or brute force, but on insight, curiosity, and the willingness of one person to see what others overlook. That single welded angle on a steel plate, placed quietly, carefully, without fanfare, had rewritten the expectations of battle and quietly saved lives that would, in turn, shape the post-war world. And in the quiet corners of shipyards, long after the last shell had fallen, welders would nod to one another in recognition. Small acts of brilliance, patiently applied, and can endure far beyond the sparks that created them. Long after the war ended, the ships themselves became silent monuments to the ingenuity of those who built them. Veteran sailors, now civilians, would recall the tactile memory of steel beneath their hands, the subtle angle of a plate that had deflected what should have been a fatal blow. Some could still trace the contours of the welded plates in their minds, remembering the first time a shell glanced off a hull and the collective gasp that rose through the crew. It was a small, almost imperceptible victory in the midst of cataclysm, yet it resonated far beyond the immediate moment. Shipbuilders and welders who had worked on these destroyers carried the lesson forward into peacetime industry. The subtle understanding of how material properties, geometry, and human ingenuity intersected became a foundational principle in post-war naval architecture. The same minds who had spent nights aligning steel plates now contributed to peacetime infrastructure, commercial shipbuilding, and even early missile systems. The techniques pioneered out of necessity during desperate conflict informed decades of engineering, long after the guns fell silent. Families of the sailors who survived passed down stories that were equal parts cautionary tale and quiet inspiration. A son might hear how his father had been on a destroyer that took a hit during a typhoon and of fire, yet returned home intact because of the way the steel was angled, and understand that survival was not merely luck, but often the product of foresight and care. In homes across the United States, tales of the Pacific Theatre were tempered not just by the scale of battles, but by the human-scale ingenuity that made survival possible. These anecdotes, often shared in hushed tones at family dinners or veterans' reunions, kept alive a memory of the invisible hands behind the machinery of war. Academics and naval historians began to study these subtle modifications, seeking to understand how small design changes could yield disproportionate results. Papers appeared in journals analyzing hull deflection angles, stress distribution, and the micro-adjustments made by shipyard workers. While the broader public celebrated the victories of fleets and admirals, scholars quietly recognized that the survival of ships and men often relied on the incremental genius of workers, whose names would never appear in textbooks. These studies not only documented the historical reality, but also influenced modern naval engineering, proving that even in the largest systems, human insight remains irreplaceable. Yet, the story was more than technical. It was also deeply human. For every hull that deflected a shell, there was a sailor who returned to write letters home, hold his children, or continue service. The psychological weight of survival, knowing that a single, deliberate act in a shipyard had preserved life, created a profound bond between those who built and those who fought. It reinforced the essential truth of wartime production, that the individual, whether on deck or at the workbench, could influence outcomes in ways that exceeded rank, doctrine, or sheer firepower. In retrospect, the war demonstrated that victory was a mosaic of both grand strategy and micro-level ingenuity. Fleet movements, amphibious landings, and intelligence operations were decisive, but the smallest details, the angle of a hull plate, the placement of a rivet, the timing of a weld could shift the odds in life-or-death situations. This tension between large-scale operations and minute craftsmanship became a defining characteristic of the Pacific theater, and, by extension, of the industrialized war effort itself. As decades passed, the destroyers were decommissioned, their steel recycled or preserved in museums. Veterans recounted stories of survival, and historians documented campaigns, but only those who had worked the steel remembered the quiet moments when innovation had bent reality ever so slightly. In this sense, the war left a legacy not just in victory or defeat, but in demonstrating the enduring value of human judgment under pressure. The angle of a plate, the angle of a mind, could be the difference between death and life, failure and continuation, despair and hope. In the end, the story of the slanted hull plates became more than an anecdote of naval engineering. It became a meditation on the human capacity to intervene in systems larger than themselves, to apply thought, care, and subtle skill where brute force alone could not suffice. Ships that survived were not just instruments of war, they were monuments to the often invisible labor of intellect and craft, reminders that even in total war, the smallest acts of insight could ripple outward to reshape history. And so, when future generations walk the decks of museums-preserved destroyers or study the steel in archives, they may not see the name of the welder who angled those plates. But the evidence of his work endures, in the angles, the glances of shells deflected, and in the lives that returned home. In that quiet survival, the war tells a profound truth, that even amid the chaos of global conflict, human observation and ingenuity remain the ultimate instruments of preservation. Long after the war, the lessons of those destroyers echoed quietly through naval doctrine. Training manuals were revised, not just with broader tactical lessons, but with notes emphasizing subtle design adaptations, showing how micro-level innovation could influence survival. Young naval officers in the late 1950s and early 1960s studied diagrams of hull angles, steel composition, and weld techniques, sometimes tracing the lines with their fingers as though trying to grasp the invisible hand of the original craftsman. They were learning that warfare was not just about firepower and fleet maneuvers, but about understanding the interplay of materials, angles, and human foresight. Shipbuilders in the post-war years often looked back at the innovations made under pressure with a mixture of pride and humility. Those who had welded plates at odd angles, sometimes under the glare of harsh factory lights or the hum of pneumatic tools, understood that their labor had saved lives. They became instructors, consultants, and mentors in naval yards, sharing the techniques that had once seemed like wild experiments but had proven deadly effective. Their experience reinforced a timeless principle. Innovation does not always require grand designs. Sometimes it merely demands attention to detail, patience, and the courage to try something different. Veterans who survived because of those subtle innovations carried a lasting psychological imprint. They understood that war was not only a contest of armies, navies, and aircraft, but also a series of tiny, human-scale interventions that could tip the scales. Many recounted, decades later, the quiet moments aboard ship when they realized a shell had glanced off the hull instead of piercing it. These stories, often shared around dinner tables or at reunions, were deeply human tales of luck intertwined with foresight. They reminded listeners that survival was not merely chance, it was the product of someone else's careful observation and ingenuity. Naval historians eventually pieced together the importance of these seemingly minor adjustments. Journals, blueprints, and oral histories were analyzed, and a broader narrative emerged. The survival rate of destroyers in certain Pacific engagements could be traced directly to these micro-level interventions. What had once been dismissed as incidental or ad hoc engineering was now recognized as a crucial factor in operational outcomes. It was a reminder that history often turns not on grand speeches or battles alone, but on countless small decisions made by those with the knowledge, skill, and presence of mind to act wisely in moments of extreme pressure. The human cost of war remained stark, of course, and no amount of clever engineering could erase the deaths and suffering that occurred. But the story of the angled hull plates illuminated a critical truth, that human skill, judgment, and creativity mattered as much as strategy, logistics, and brute strength. It also provided a counter-narrative to the impersonal scale of industrialized warfare, showing that individual acts of ingenuity could ripple outward to affect thousands of lives. For historians and engineers alike, it was a lesson in humility, emphasizing that technology alone does not secure survival. Human observation and innovation do. Even as new classes of warships were designed in the decades following World War II, the principle remained. Engineers continued to study stress distribution, armor angling, and deflection patterns, often drawing inspiration from the empirical successes of the 1940s. The war had offered a crucible in which both design and human ingenuity were tested to extremes. The survivors of these battles, both sailors and welders, carried forward knowledge that was practical, human-centered, and rigorously tested under conditions of life and death. Ultimately, the story of the slanted hull plates endures as a quiet testament to the unseen hands that shaped the war's outcomes. While battles are often remembered for strategy, heroism, and mass movements of men and ships, the survival of individual crews sometimes hinged on small, deliberate interventions. One weld, placed at an unusual angle, became a literal shield for those aboard. One insight, born from careful observation and willingness to question standard practice, altered the odds of survival. In that convergence of skill, circumstance, and courage, history demonstrates a profound irony. Sometimes, the smallest human decisions carry the greatest weight, and so, as the years pass and historians catalogue the sweep of the Pacific War, the legacy of these destroyers lives on, not merely in museum halls, preserved steel, or technical manuals, but in the understanding that human thought and precision, guided by care, ingenuity, and sometimes intuition, can change the course of events in ways that no single battle plan or operational order could ever fully predict. It is a lesson in the power of subtlety, the persistence of craft, and the enduring importance of human agency, even amidst the largest and most chaotic conflicts of the 20th century. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out, and don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.